Hi, my name is Zoe. I research how Arctic plants respond to climate change. So why a Bob Dylan album cover, you may ask? Well, come gather around, people, and let's take a look at what's happening in the Arctic, for the times they are a-changin'. The Arctic conjures up images of great white north and a desolate beauty. Indeed, the Canadian high Arctic is considered a polar desert, and yet Arctic supports a surprisingly diverse set of plant species. For example, there are about 125 vascular plant species and numerous mosses and lichens growing on northern Ellesmere Island, and that's about as far north as you can go anywhere on land in anywhere in the world. The flowers on these plants are disproportionately large for the size of the plant and put on an impressive display of colour. In the 2 to 3 month growing season, Arctic valleys can be awash in purples and yellows. Phenology is the study of the timing of nature's seasonal events, including the timing of the arrival of migratory birds, the emergence of insects, and the timing of flowering. These phenological events are often triggered by changes in temperature. You could think of it as the plants adding a bead to a counter whenever temperatures are warm, until a magic number is reached and flowering is initiated. This mechanism prevents plants from flowering during a warm spell in midwinter. For most Arctic species, plants will flower earlier when temperatures are warmer. We call this relationship flowering time sensitivity to temperature. There are similar relationships for leaf out, fruiting, and leaf senescence. But the times they are a-changing, and indeed the climate in the Arctic is really changing. Temperatures in the Arctic are rising at 3 times that of the global average. As the climate warms, we expect some plant species to shift their flowering times to an earlier date. So what does that mean for Arctic plants? How will Arctic plants respond to climate change, and will it affect Arctic plant biodiversity? Plant phenology plays a key role in ecosystem function. The time from leaf out to leaf senescence defines the growing season length. The timing from flowering and seed dispersal defines the plant reproductive success. We can use natural history collections to find out how much phenology has shifted and how sensitive phenology is to temperature. Botanists have been collecting plants from the Arctic for well over a century now. The plants are often collected in flower or fruit, as these plant structures help identify plant species. The collected plants are pressed, dried, mounted on paper, and most importantly, labelled. Herbarium specimens are great sources of flowering fruiting time data. The label on the specimen indicates where and when the plant was collected. This provides a time series, if you will, of when species were in flower and fruit. From Arctic specimens, we have found that seed dispersal times have shifted earlier by double that of flowering times. This may reflect greater Arctic temperature rises at the end of the growing season than at the beginning. The herbarium specimens also suggest that some species exhibit greater flowering time sensitivity to temperature than others. For example, Arctic lousewort flowering times are more sensitive to temperature than those of arnica, which are more sensitive to temperature than those of fireweed. Herbarium specimens have been collected from all over Nunavut, and interestingly, they show that flowering times responses to temperature vary across space, suggesting that plants may be adapted to the environment they live in. So what does this all mean in terms of plant biodiversity? Phenology is thought to be linked to plant fitness, such that there could be negative fitness consequences if a plant's phenology becomes mistimed with favourable climatic conditions. If some species are able to shift their flowering times in line with climate change while others lag behind, there are likely species that will benefit from climate change, but also species that will likely be at risk from climate change. So as the climate warms, Arctic plant diversity may shift towards species that benefit the most from climate change. For example, we are already seeing Arctic shrubification, where shrubs are becoming more dominant in the Arctic landscape. I will end with some final, somewhat prophetic words from good old Bob Dylan. Thank you for listening to my talk. As the present now will later be past, the order is rapidly fading, and the first one now will later be last, but the times they are a-changing.